Good day, viewers at home. You are welcome to Mathematics Lab with Mr. Major. Today we'll be looking at lesson 3. And the topic is relationship. The relationship between indices and logarithm. The relationship between indices and logarithm. We have talked about indices in our lesson 1 and lesson 2. Now, you will recall that in indices, if I have something like 8 can be written, 8 can be written as 2 raised to power 3 in indices. This is 2 raised to power 3, that is in indices, where 8 is the number. 8 is the number or the argument. 2 is the base. Then 3 is the power or the index or the exponents. That is in indices, which means 8 is equal to 2 raised to power 3. Now this power is what we call the logarithm of 8 to base 2. So in logarithm, we call the power, which in this case is 3, is called the logarithm of 8 to base 2. That means the power to which 2 must be raised to give you 8. And this is how we write it in logarithm. Logarithm of 8 to base 2 is equal to 3. The logarithm of 8 to base 2 is 3. So this log here, which is log, is the short form of writing logarithm. It is an abbreviation for logarithm. So we say the logarithm of 8 to base 2 is equal to 8. Now, we can also turn this to index form. If you want to turn this to index form, it becomes 2 raised to power 3. This is the base, this is the power. So this base raised to this power, which is 2 raised to power 3, is equal to 8. So this is the logarithm form, this is the index form. So we can be given a question written, we can be given an expression that is written in logarithm form like this, and you will be asked to write it in index form. This becomes the answer. You can also be given an expression in index form, and you will be required to write it in logarithm form. This will not be the answer. Let's look at another instance. Supposing I am given something like 5 raised to power 4 equal to 625. Of course, 5 raised to the power of 4 will give us 625. If we are not asked to write, this expression is in index form. It is in index form. If I am not asked to write it in logarithm form, it will be the log of 625, which is the number. So the base here is 5. That means the log of 625 to base 5, and the power is 4. So it's equal to 4. Meaning the log of 625 to base 5 is equal to 4. Let's take note, please, so that we don't mix up the numbers. The base is usually here. The power is this. Then the number, which the value of this is the number that is always here. So log of 625 to base 5 is equal to 4. So supposing we have something like Okay, let me give one in logarithm form, then we change it to index form. Supposing we have something like log 100 to base 10 equal to 2. This is the logarithm form. This is the logarithm form. Now, if I am asked, or if we are asked to write it in index form, it becomes 10 raised to power 2. 10 raised to the power of 2 equal to 100. So we always raise this to this power, raise this to this power, and this becomes your answer. So in general, what I am establishing here is that if we are given something like a raised to power x equal to n, then in logarithm form, it becomes log of n to base a equal to x. This is the general form of it. This is the index form, and this is the logarithm form. And this is applicable to all instances. I will now look at some examples. Let's solve some few questions based on this. The first example we'll be solving today says that we should find x if log x to the base of 2 is equal to 5. Now, solution, we have log x to the base of 2 equal to 5. We have established earlier that this is the base and this is the power. What that means is that 2 raised to power 5, which is this 2 raised to power 5, is equal to x. Now we know that 2 raised to power 5 means 2 multiplying itself 5 times. That is 2 times 2 times 2 times 2 times 2. And 2 raised to power 5 will give us 32. So the value of this is 32 equal to x. What that means is that our x is equal to 32. So what this expression means is log 32 to base 2 is equal to 5. The second question on the board here, example 2, says that we should find y if log 1 over 36 to base y is equal to minus 2. Now, solution. We have log 1 over 36 to base y equal to minus 2. Again, this is the base, y, and minus 2 is the power. So we write it in index form. That becomes y raised to power minus 2 equal to 1 over 36. This is the same thing as y raised to power minus 2 equal to, according to the negative law of indices, anything raised to a negative power is equal to its reciprocal raised to a positive power. So now, what that means is that if 36 is raised to a negative power like this, it is the same thing as 1 over 36. So since these two terms are equal, so I can write 1 over 36 as 36 raised to power minus 1. Now, when we solve in these initial equations, we said if the bases are the same, we equate the powers. Or if the powers are the same, we equate the bases. So we need to make, in this case, since the base here is an unknown, let's see how we can make the powers the same. So this becomes y raised to power minus 2 equal to 36 is the same thing as 6 raised to power 2. So we have 6 raised to power 2 as 36 rather, then raised to power minus 1. This will now be y raised to power minus 2 equal to 6 raised to power 2 times minus 2. 2 times minus 1 will give us minus 2. So now the powers are the same, minus 2 here, minus 2 here. So we can equate the bases and say our y is equal to 6. So the value of y here is 6. That means log 1 over 36 raised to log 1 over 36 to base 6 equal to minus 2. All right, question 3 says we should find x if log 0.01 to base 10 equal to x. Again, 10 here is the base, x here is a power, so this means 10 raised to power x. So we have 10 raised to power x equal to 0.01. So we now have 10 raised to power x equal to, let's change 0.01 to a fraction. If you change 0.01 to a fraction, that will give you 1/100. So we now have 10 raised to power x equal to, let's write this with negative power. So that becomes 100 raised to power minus 1. So we now have 10 raised to power x equal to, writing this in terms of 10 like this one, that becomes 10 raised to power 2. Because 10 raised to power 2 will give us 100. Then multiplied by minus 1. That means we have 10 raised to power x equal to 10 raised to power 2 times minus 1 is minus 2. The bases are the same now, so we can equate the powers. Therefore, our x is equal to minus 2. This is the answer. So we are having the same answer as in example 2. Log 0.01 to base 10 is equal to minus 2. Okay, I will leave you with this biscuit on the board. Just try and chew them. The first one says that you should write the following in logarithm form. You have 2 questions there. Then the second one, number 2, write the following in index form. You also, okay, you have 3 questions there. Then the third one, you have to find the value of x. If log x to base 4 is equal to 3, and then if log 1/343 to base 7 is equal to x. So try and solve those questions, these questions. Drop your final answers in the comment section. The person that will get the answers to all these questions will be given a prize. Please, I want to request that if you've not subscribed to my channel, please do so. And if you are watching from Facebook, follow my page there. If you are on YouTube, subscribe, like my videos, share them with your friends so that they will also benefit from these lessons. Thank you.